So let's keep going with the exercise. I'm going to load the gas PVT. Oh, sorry, Iramar Vasquez asked about what's the difference between Jupyter and Anaconda. So Jupyter, it's just an application. It's a integrated development environment for Python, R, and Julia. And as such, it's an open source application, and that's it. It's an application. Anaconda, it's actually a company. So if you Google for Anaconda, you will realize that it is actually a big company that provides enterprise support to companies, to other companies around Python solutions and some other things. So Anaconda, they have an annual conference, AnacondaCon as well. It's quite good, and they develop some open source packages. And so if you see on open source technologies, I believe that NumPy, Pandas, I'm pretty sure that Anaconda are the ones promoting those packages. And they have a Conda. Conda, it's their, as I mentioned, their equivalent of pip, but it's a more multi-programming language package manager. And they have Anaconda Navigator. The Anaconda Navigator, it almost like makes you easier to work with Jupyter, and set up your environments and so on. But it's a good place to start. Once you understand how to get in, and once you understand how to set up your environments, how to install your libraries, and where is it that you're running Jupyter from, and whether you want to migrate to other IDEs like PyCharm. PyCharm is my preferred editor, but I think PyCharm could be quite confusing in terms of functionalities. And at first, Jupyter is it's very simple to read, but PyCharm is a bit more confusing. But in any case, Anaconda gives you an environment where you install the environment, the libraries, and then you can open the applications on top of those environments. I hope that was clear. Two completely different things. So Anaconda is an enabler, a facilitator to use Jupyter, to use PyCharm, to use other stuff. Right. So let's crack on with the example. Now I'm going to do the same for the gas PVT. So let me copy this. I'm going to load the PVT, the gas PVT, and this is called set factors. It's on the, we're going to skip three rows, and we're going to load 12 rows. So this is again set factors, 3 rows, and we're going to load 12 rows. So let's see if that actually makes sense. Okay, pressure set, formation volume factor of the gas. I'm going to do exactly the same to convert some of the input data to the names that we need to use in the library. And the only thing that we need is the pressure and the, oops, sorry. And the gas formation volume factor. And this is the gas PVT. We're going to use this dictionary here, and this is the data frame for the gas. Let's see if that worked. Okay, pressure. Oh, I have oil FPF. That's not good. Oops. I'm using. Let me do this again. Solution gas is not in index. Of course, I just need pressure and gas. There we go. Right. So the next thing that we're going to do is define the initial tank properties. And for that, we're going to use a dictionary. So let me go to Markdown, and I'm going to define initial tank and fluid properties. Right? So I'm going to copy and paste the dictionary here that we need. I'm just going to modify some of the numbers to make it a bit more interesting. And we'll see that we'll see the effect in a bit. So let's imagine that I have my original oil in place of 10 million barrels. It's very small, as you will see in the example from the Excel. The initial gas cap, initial pressure, initial water aquifer size, injectivity index of the aquifer, water saturation, compressibility of water and formation volume factors for oil and gas. And for the PVT, original the GOR at saturation pressure, and what's the temperature of the reservoir? What's the reservoir temperature? Right. So far, we haven't done anything with the material balance library. We haven't done anything. The only thing that we have done is import the data frame for production, import a PVT for oil, and import a PVT for gas, and define a couple of dictionaries, one for the tank and one for the PVT. That's all we have done. So this is where we're going to now initialize the library. So let me put this as initializing a RE matval library. And for that, I'm going to import from the library from RE matval. I'm going to import the main, import the tank. So the tank is a tank instance, and I believe let me put here tank. I'm gonna call this tank data to avoid confusion. Tank data. So now I can create a tank. Let's call it tank one. It's what is equal to tank. Oh, let me load this again. Make sure that it loads. It's running, loading. Okay. So this is equal to tank, and I'm going to just initialize this tank. The way this works is tank is an object, and as an object, you have to define what are the things that you are going to use for the tank. So for tank one dot, let's see what we can do with the tank. We can specify the tank data. So the tank data is equal to tank underscore data. The tank production table is equal to df prod that we already loaded. Tank one dot gas PVT table is equal to df PVT gas. And for the oil PVT table is equal df PVT oil, and we need a PVT master as well. Tank one dot PVT master is equal to this variable here, PVT master. And that's it. For this exercise, I'm going to, one thing that we can do is make a regression with the tank. For this exercise, I'm going to deactivate the regression. I'm not going to cover on this exercise today. So I'm going to set it to false. And I have some other configuration files or setup, configuration setup that I'm going to set it to none for the sake of this exercise. So if I want to run the tank, I can do tank dot matval run, and that's it. I should be able to run the tank. So I'm going to return this function, return the time series. You can call it whatever you want, but you can call it, let's say, data frame results, and also tank results. And the tank results is just in case if you're running an optimization and these numbers are being modified, some of these numbers are modified, but for the sake of this exercise, the tank results will be exactly the same as the ones that we have put in the tank data. Okay, okay, awesome, that didn't work. Sorry, it's tank one dot matval results. Okay, so that's not good. It seems that we are missing some information. Let's run it everything from the beginning. Okay, there's something going on wrong, but if I show you what's happening, the DF results, let's see if that's coming with something. Yeah, so that's coming with calculated pressure, depletion index, drive index, segregation drive index, and so on. I'm not quite sure what is going on. Let's see if skip roads. This is fine. You know what? For the time being, I'm going to avoid to remove these additional columns. And let's run it again, see what's going on. Yeah, something it's so it's the solution is making a progress, and I'll show you what's how I know it's making a progress. I've been working with this already for some time. So let's do something a bit interesting here, and I'm going to create a plot. But we're going to use Plotly this time. We're not going to use Matplotlib. I like a lot the library Plotly because it's a bit more interactive. You can do some zoom. You can hover on the data and do some more analysis on the data. So I really like it a bit more than Plotly. It doesn't play as nicely as Plotly in Jupyter in the notebook, but I'll show you what things that we can do. So the first thing that I'm going to do here at the top, it's I'm going to import Plotly. I'm going to import these couple of things. So the Plotly library, I'm going to import my objects. I'm not going to explain in detail how Plotly works, but just going to use it. The initialization mode, just to make sure that I work with Plotly offline, because there is an online version where you can upload your plots to the web, and then you can do edits and so on their server. We don't want to do that. So let's do this, run these couple of things. And as I mentioned, the Reservoir engineering library has some some plotting functionalities already in the library. So if you go into the library and go into plots, the library is returning a pressure plot, and it's returning a drive indices plot. These plots, all this setup that you see here, it's especially designed for Plotly. This wouldn't work in, these are actually working with Plotly. They don't work with Matplotlib. So if you want to use Matplotlib, you will have to write your own library. So what I'm going to do is generate a plot one. It's equal to plot, and I need to import instead of I need to import from RE matval. I'm going to import plots as plots, and this is actually this library that you see here. Okay, I'm gonna call it plots RE plots, just to avoid any confusion with the Plotly library itself. So I'm gonna call it RE plots. Oops. Import, sorry. Import plots as RE plots. Okay. So I'm gonna do then RE plots dot, and now I can access the library, the pressure match plot, right? So what I want to do, this library receives for pressure match, just as this Excel, it receives the X and Y for the observed data and the X and Y for the calculated data. So I'm gonna put the calculated data first, and this is DF results, DF results, and I'm going to put time and DF results. What happened there? DF results calculated pressure. Let's put the calculated pressure here. And also the DF plot in days and DF plot in, I believe it's pressure, isn't it? So what's happening here, it's if I show you what is in plot one, the library is just returning the plot data, that I want to create in Plotly. So that's all the library it's doing. So I can now use the plot library, the create a figure with that, and I'm just gonna plot figure one, or is equal to Go, which is the offline library for Plotly figure, and I'm going to specify that the data it's the one that I have got from the library. Okay, I have a plot. Doesn't mean that I'm looking at the plot at the moment. Let's see what I have in there. It's you will receive a bunch of I believe this is it's not printing anything, HTML code or something. But then we can use a plot offline library to say I want to do the plot figure one, and I want to save it in a file name. Let's call it pressure match or mismatch in this case .html. So this is going to be an HTML file. Let's see if that works. So if I go back here, nothing it's been run. It's interesting. Well, there is something that I missed that I wasn't quite sure if I needed to use, but it's this init notebook mode connect false. Let's see if that works. It's doing something. It doesn't seem to be exporting any file. Oh yeah, there we go. Okay, so here's the first plot. Not as nice as you might be expecting it to be, but let's talk first about the functionalities that we have here. So first of all, this is an HTML file. In fact, I can close this, and I'm going to open this in here. And some stuff that you can do, it's actually put it side to side. So let's trust this HTML. There you go. Let's open some space here. Okay. So of course I'm zooming in and it doesn't look as nice, but there you go. So you have your plot and you have your you have your code next to each other. So it's a bit of the Jupyter Lab is becoming a bit of a dashboard if you think about it. And the other thing that I can do, so it doesn't open that file every time on another tab, I can do auto open equals false. And so now it's not opening, but I need to press the refresh button to get the file, the update version of the plot here again. So there is something wrong with the library, with the calculation. I'm not quite sure what is it that might be wrong. Let's try to figure it out. It just happened to me before, but so far, let me see what's. I'm going to run it from the top. So I have days, I have NP, the gas production, WP. I have pressures, observed pressures, date stamp, water injection, gas injection. So I don't think I'm missing anything there. Hold on a second, let me see if I'm missing anything there. The gas production, setting up to tend to converting it to standard quick fit, that's fine. So the PVT for oil. So I have pressure and oil formation volume factor, which seems okay to me, and I have solution gas. And we also have skip rows, so we're skipping 3 rows and loading only 16 rows of data. So that looks fine to me. Let's do the gas slowly. Let's see what's going on here. So we have pressure set and gas formation volume factor. Again, it looks okay. Nothing that I can notice here that is strange. And the tank data, apart from the numbers that I have modified, let's see what's, put it more to the original values of the tank. No, still failing. Plot table, tank data, PVT master data, regress, set to false. I'm not sure what's failing. I need to check, and probably will take me more time. But the last thing that I want to show here, and it won't be nice because it's not actually loading nicely, but there is a drive index plot as well. So if I go and do a plot too, and again RE plots dot plot drive indices, I can set up a drive index plot with all the these indexes that I have here. So the F results, and let's put the axis as time. The F results, and I'm going to put the depletion drive index. The F results, segregation drive index. You get the idea. So I have a plot. Again, if I have a look at the data, the only thing that this is doing, it's preparing, it's just sorting out the data in a way that I can, we can pass it to Plotly. So it's just specifying that which colors we want. So all this coloring that we have in there, the name of the access, whether if it's a stack or not. So it's a bit of a library just to make sure that we have a nice plot. So I'm going to just copy here. So go figure data plot 2 and data drive index student, just to make sure that I don't overwrite the other one. And in theory, if you run that one, you should see something similar to this one. So you should see the drive indexes, which ones are the predominant drive indexes as you start to produce. There's something wrong here that I haven't figured out what's going on, but something to study a bit more. And actually, if I show you the actual plot as we should see it, let put it in here. So this is the actual pressure match that you should see at the end. And just to close, some of the advantages that I see on using Plotly, it's first of all, when I hover on the data, I can see what's happening with the data. So I can actually hover and get the actual number that I'm plotting. With Matplotlib, I believe you don't have that functionality. You also have controls on the zoom. So you can do things like I'm going to zoom on this particular area. Nothing that you may want to do, but you can also select data that might be useful for other functionalities. Zoom out, zoom in, go back to your home, and you can also produce go to Plotly to the Plotly website and start to play with that plot. But I'm I'm not going to go through that at the moment. So how to scale, you can download plot as a as a picture as well. So those are some of the functionalities of Plotly, move the plot around and so on. It's I find quite a good library. Well, I think that that's it for the day or for the night for me. And I'm going to stop here and ask for any questions that you may have or any comments. So let's start with questions. It can be from any point from the beginning or from what we discussed at the beginning. So far we went through the Python environments discussion. I showed you the difference between Anaconda, how Anaconda wraps around the environments with the Conda, and also how you can do it with the pip and package manager. I show you how to include your RE-MATBAL library and how to install it or use the library in your project. And what is it that what you could do with the library? So far, I've done only the part of the history, and something that we need to do as we go forward is a prediction. We set up the example with the LSU spreadsheet, which is a quite useful example because you can actually see in Excel what we're trying to achieve with Python. So you can do your own sort of in-depth analysis. And we are using Jupyter a Plotly with Jupyter Lab as well. And I'll show you a bit of a simple functionalities of Jupyter Lab, having different windows where you can put a command line, arrange a plot on different areas, and then start to build a bit of your own dashboard inside Jupyter Lab. So I hope that was useful as a session. So any questions so far, please?